Join the conversation. Tweet us at BSides Cincy. The presentation will begin shortly. BSides Cincinnati 2018 is sponsored by GE Aviation, No Starch Press, CBTS, CYBERARK, Booz Allen Hamilton, Dark RHINO Security, ENDGAME, RSA, and US Bank. Join the conversation. Tweet us at BSides Cincy. The presentation will begin shortly. BSides Cincinnati 2018 is sponsored by GE Aviation, No Starch Press, CBTS, CYBERARK, Booz Allen Hamilton, Dark RHINO Security, ENDGAME, RSA, and US Bank. Join the conversation. Tweet us at BSides Cincy. The presentation will begin shortly. BSides Cincinnati 2018 is sponsored by GE Aviation, No Starch Press, CBTS, CYBERARK, Booz Allen Hamilton, Dark RHINO Security, ENDGAME, RSA, and US Bank. Join the conversation. Tweet us at BSides Cincy. The presentation will begin shortly. BSides Cincinnati 2018 is sponsored by GE Aviation, No Starch Press, CBTS, CYBERARK, Booz Allen Hamilton, Dark RHINO Security, ENDGAME, RSA, and US Bank. Join them.
All right, everybody, we'll get started with the 3 o'clock talk here. So I'd like to welcome Jeff Archer to the stage to talk to us about Phishualize and some computer vision software he's been working on. So take it away, Jeff.
Thank you. Thank you guys so much. And the first thing I want to do when I come up here is thank you guys so much for coming out here. As you know, it's our 5-year anniversary. This is a fantastic turnout for the 5-year anniversary. The speakers we've had today have been phenomenal, right up to about now. And we really appreciate you guys coming out and supporting this. It's always great to get the community out here. So, as Mr. Omer said, my name is Jeff Archer. I work for, I work for GE Aviation's Cyber Intel team. Don't have an About Me slide because honestly it probably wouldn't amount to a large slide. I've been with GE Cyber Intel for about 2 years now, 3 years if you count a contracting year, and been in security in general for about 5 years. On the military side, I've been in signal and cyber, and that's pretty much all you need to know about me. Today though, I want to talk about one of the more recent projects we've been working on called Phishualize. Like Danny, we also like to make up fun words. Phishualize is a computer, like Josh said, it's a computer vision tool that I hesitate to even call it a beta at this point because we just began hardcore development on it at the beginning of this year. So take that caveat throughout this talk. This is something that we're working on. We have a long road ahead. Down the road, this is something we definitely want to, if possible, still going through the legal proceedings and getting the blessing from them, open source the community and open it up to the world. There's a couple startups doing this kind of thing. But we built this from the ground up, and we'd really like to get feedback and other people working on it as well. Before I get into the details of the tool, though, I wanted to kind of talk about the impetus of this idea. This is one of those rare times as a developer, and rare awesome times, that you have this crazy idea and it turns into a reality. And sometimes it's beyond what you ever imagined it would be. So talking about the impetus for this idea, where this came from, there are two primary sources of inspiration. And the first one was this graph here. Now, I've redacted a lot from this graph. But to give you some context, to color this in a bit, you're going to see a percentage of phishing events over a year-long period. I won't say which year. And this is not just GE Aviation, but this is GE all the businesses. And this is not all the emails and phish we have coming in, but this is what made it through the first layer of defense into our detect and incident response team, who have to, it's humans actually analyzing these alerts. So, to give you an idea of our volume here. Number one, that says geo-targeting, so phish that are targeting employees in a specific region of the world. That's a small 0.06%. Office macros, 0.09. Malware droppers, spam, Java malware, crimeware, BEC or business email compromise. That's where you have a supplier or a customer who either gets compromised or they get spoofed, and they email your finance department and they say, hey, our bank account has changed all of a sudden to this bank in Nigeria. Can you please send that $90,000 to this bank in Nigeria instead? And your finance account does it. That's BEC. And up to now we're up to maybe 1% social engineering. That bumps us up another 2% of volume. Malware, we do get a lot of malware, so that brings us up 20%. But there's the rest of that 100%. And that says right there, credential harvesters. For those of you who don't know, I'm sure most everyone in this room does. Those are your fake login pages, which, you know, they try to spoof the Gmail login or the Adobe login. And the users, to the untrained eye, it's very easy to be deceived. They put their credentials in, and now the attackers have them. It's really frustrating to see metrics like these working in our realm, because for us, we have the trained eye. We can spot it a mile away. It's very easy for our incident response and detect analysts to look at these alerts and see right off the bat, this is a credential harvester. And yet, this is what they're spending all of their time and energy on, when they could be working on these events over here, which arguably could be more serious. Credential harvesters, they can be serious. They're the path of least resistance for a lot of attackers, from your script kiddies to your APTs. But we knew we needed a solution, because having this talk with leadership, it's not a good talk. Because what they hear is we're spending all this time on these low-level attacks. And anytime an executive hears the word time, that immediately equates to money. And then our only solution at that point, when we're having these conversations, is, well, we could use more headcount. And again, all they hear is money. And I don't know if you've seen GE stock price lately, but we don't have either of those things right now. So this left us in a little bit of a conundrum. We started exploring some solutions. For example, you can take a look at the source code for a credential harvesting page. It's going to be obviously different than the Gmail source code. Sometimes they spoof bits and pieces, but there's going to be something in there that's different. The trouble we ran into with that is stuff like base64 encoding the entire page, or little JavaScript tricks, or a bunch of redirects. There's a lot of little things that can interrupt your automated analysis if you're just pulling the source code for the page. So at this time, we didn't have a solution. That comes with the second source of inspiration, which came a little bit later from a hit HBO series that I think most people in this room will be familiar with.
It's ready.
Please.
What will you say if I told you there is an app on the market?
We're past that part. Just demo it.
Okay. Let's start with a hot dog.
Holy shit. Yeah, it works.
Oh, mother.
Huzzah!
Jin Yang, my beautiful little Asiatic friend, I'm going to buy you the palapa of your life. We will have 12 posts, braided palm leaves. You'll never feel exposed again.
I'm gonna be rich. Guilfoyle.
2 pizza.
Yes, 2 pizza.
Yeah.
Okay. Pizza.
Not hot dog.
Wait, what the?
Huh?
That's it. It only does hot dogs.
No, and a not hot dog.
I promise our idea is a little better than that, a little bit. But that was good inspiration. So that kind of kicked off the idea that we're going to need something that we can emulate that analyst eyes. Those analysts, like I said, they can see that from a mile away. They can easily look at a credit harvester and know what they're looking at. And so then I started digging back into OpenCV docs and computer vision research documents. I reached out to Dr. Adrian Rosebrock. If you know him, he's on Twitter as PyImageSearch. He's written 2 great books on Python and computer vision and machine learning. So digging into all that stuff, I knew that we had a chance of a good solution if we started working with some of this computer vision stuff. So, in summary, Phishualize is a service that renders websites through some kind of anonymization service, and we do that just to prevent any IP leakage. For those who don't know, GE owns an entire Class A, so it's very easy to tell when GE is looking at your stuff. So in order to avoid that, we run the URLs through an anonymization service, we pull back a screenshot, and then we run some computer vision algorithms on them and make some assessments within this module automatically to determine whether the site is going to be malicious, spoofed, or benign. And when we came up with this idea, we wanted to make it accessible to the small companies, the companies like GE, the larger companies. We wanted to make something that would stand alone by itself and also plug into existing pipelines. For example, we already have an existing pipeline for doing email detection. It's a tool called PhishFinder, a little hard to see. But in a nutshell, what PhishFinder does is we essentially start with a network tap that reads all the external to internal emails coming in. And we run those messages against our internal intel set. And within that intel set, each of those rules gets a score. So if there's a score above a predefined threshold, that gets sent off to the PhishFinder queue where our human incident response analyst will triage that alert and determine whether it's an actual false positive or a true positive. If it's a false positive, nothing much happens. We just mark in our metrics. It helps us refine our intelligence a little bit. But if it's a true positive, we can automatically scrape intelligence from that, like senders, IP addresses, common subject lines, stuff like that. And then we can remove the fish from the user's inbox. So the end result of the PhishFinder pipeline here is that we're doing a kind of manumatic process where the incident analyst has to go in and triage it, but once they do, if they escalate something, on the back end we can automatically document that phishing incident, collect the intel and deploy that intel, and remove the threat from the environment. So right now we're thinking Phishualize will fit somewhere between these 2 steps where we didn't want to put it for all of the emails coming into GE. That's a massive amount of emails and a massive amount of processing to run a computer vision tool against. But if we have a message coming in and it's already hitting some piece of other intel we have, we might as well throw it through Phishualize and see if we can make an automated determination about whether or not it's malicious. Save our analysts some time, cut down a little bit on the false positives. So this is just a high-level overview of the technologies we're using here. The input, of course, is our URL. We're using Koa middleware. What that does is it just kind of does the routing and mounting between the back end and the front end. So Koa is going to take that URL and it's going to send it over to Puppeteer. Puppeteer, for those who aren't familiar, it's headless Chrome or Chrome without Chrome. Basically, you can feed a URL and it will grab that URL, throw it through the anonymization service, and bring us back a screenshot. When the screenshot arrives, Koa routes that through to the classifying module, and that's written in Python. The classification module is where the computer vision magic happens, and then the output from that process is given to the analyst so that they can make a better determination on this message. Now, eventually, once we train this thing more and once we build out our libraries, we could potentially start just making that a completely automatic process where it will automatically triage these alerts. We're still a long way off from that, but that's the end goal in mind. So taking this one level deeper at the actual breakdown of this project, the way we structured it, we have a cache here, and that's going to store our URL screenshots, and it's also going to store a second screenshot with any templates that get matched, circled in a red line. And there's also a JSON file that gets stored in here that more structurally describes that data, whether it found something malicious or, the basic question it's asking is, does it make sense that we're seeing this set of logos on this URL? And it's going to capture that in JSON, and that's what's going to kind of feed back through to the analyst view. And the way we're storing these, by the way, is we're going to take an MD5 hash of the URL. That way, if we get the same URL coming through multiple times, we don't have to keep classifying it because we don't want to waste too many cycles. So if the hash already exists in the cache, it'll just pull the data it already has, and it saves us a lot of time. Then we have the classification module itself, again, written in Python. Underneath that folder there, we also have this template library, and you'll hear me talk about templates a lot. I kind of use that word interchangeably with logos. These are the things we're basically looking for. So you can see we have all these different, I call them tags, or different services: Microsoft, Office 365, OneDrive, Outlook, Yahoo. Each of these services has their own kind of logos. So what Phishualize is going to do is say, okay, I found logos for this, this, and this service. And then it's going to look at that URL and ask the question, does it make sense that these logos appear on this URL? And that's how it's going to, in a very simple way, make that determination about maliciousness or spoofing. Now, along with each of these template sets, we have a metadata file here, also in JSON. And I'll show you an example of that at the end of this presentation. In that metadata file, we can tweak these as much as we like. We can set different thresholds for each template. So if you have a template like the Gmail logo is a good example, that envelope can look like a lot of things. It can look like a wide letter M. It can look like a lot. And so we have to set a slightly higher threshold for that logo compared to the other templates we have. Other things you can tweak with this is the whitelist, of course. So with each logo, you're going to have a set of whitelist. Obviously, if we find the Outlook logo on the Outlook website, we don't want to classify that as malicious or suspicious. That makes complete sense. And then, of course, you can designate whether you want to turn the template on or off. And there's a lot of room for customization and tweaking with your own internal intel set and observations here. And then, of course, we have the source, the front end for this proof of concept, which is written in JavaScript. So I want to dig a little deeper into the magic that's happening underneath the hood of this classification module. We're using a classic computer vision method called template matching. And it's a super simple concept on paper. Essentially, we have an input image, and we have all these logos. And we're going to see all the places in this input image where that logo appears. Very simple concept. You probably do it, you do it, I'm telling you, you do it every day. If you have, an I Spy book or Where's Waldo book that you take from your kid or someone else's kid, and you're trying to show them how it's done, what you're going to do, your brain knows what Waldo looks like, and what your eyes are going to do is scan across those pages and look, trying to find where Waldo is. And this is exactly what we wanted to emulate with Phishualize. Now, it's a simplified animation, but the idea is there. Now we get to the complex part. Because for us, it's really easy to say, hey, that's Waldo. I can see him. He's right there. But how do we teach a machine what similarity looks like? And so without getting too deep into the mathematics and the theory here, I want to talk about this value called the cross-correlation value. To put it as simply as I can, it's essentially a sum of products. So we have our input image. We have our logo. Just like you saw in that animation, we're going to start with that logo in the top left corner, and now we have an overlapping region of pixels. So if I take this pixel in the logo at, let's say, XY, position XY, take that same position in the input image, and multiply them together, that's going to give me the cross-correlation value. And you do that for that entire region, and you do that, you slide the logo across the entire image, and you go back and you see where's the highest correlation value, and that's going to give you your best match. It's a little hard to picture how this works, especially for, if you have a development background, we tend to think of like pixel intensities. We think RGB and 0 to 255. I think it's easier to understand this concept if you think, okay, 0 is absolute neutral. And then if a pixel is darker, you go negative. The more dark it is, the more negative the number is. If it's lighter, it goes positive, or you can do vice versa even. So, when we have a logo, and we have a pixel here, if that pixel is light, it's going to be a positive number. Same thing, if the input image is also light, that's going to be a positive number. We multiply those two together, we get a larger positive number. On the other side, if the pixel is dark, and the input pixel is dark, that's going to be two negatives multiplied together, that's going to be another positive. So that's how we get the end result that the cross-correlation value, wherever that's highest in the image, is going to be the region of highest matching. And we actually tweak this even a little bit more by using what's called the normalized cross-correlation value. And what that does is we're simply just subtracting the average brightness of the entire picture from each of these. And what that handles is a case where if an attacker slightly brightens or darkens their credential harvester or spoof site, that won't mess with our matching. Say that we have, the original red Adobe logo and they have a slightly pinker Adobe logo. Our matching will still work using the normalized cross-correlation. So, that's it. That's the magic that goes into template matching. It's not all that complicated. It's just complicated to get the concepts down. We're actually going to twist this a little bit more because with template matching, you can either get a bunch of different size templates of the same, logo, like 100 different sizes of the Adobe logo, or you can scale down the input image. So we decided to scale down or go across scales of the input image. So what we're going to do is use a process called scale invariant template matching, which is just a fancy way of saying we're going to take that input image, we're going to blow it up to maybe 200, 300% and start there, run that logo across, look for matches, and then we're going to do that again and again, just scaling down that input image. That way, we only have to keep one Adobe logo template, and we can use that to match across multiple sides of the same image, just in case they blow up the logo on their page or they make it smaller or whatever. And we can actually speed this up even more if we make a couple of tweaks. Our goal here is to scale this obviously to the amount of email that we're getting in, which is quite a large amount. So we want to be as efficient as possible. Well, we can save ourselves a few calculations going back to talking about that cross-correlation value. We have to multiply the pixel intensities together. Well, we could do that for two color images, but you have to take that product for the red channel, the blue channel, and the green channel. But if we grayscale both the images, now we're down to one channel. That saves us a couple calculations. Now we just have to do multiplication 1 to 1. Other thing we can do is use a technique called edging. And all we're doing there is taking the edges of both images. If you think about it, anything you're looking at, it's mostly made up of its edges, any shapes you look at. And it's the same thing for the machine, what it's seeing. So this reduces it down for our classifier so that our classifier can say, okay, I'm looking at this pixel. Is it an edge or is it not an edge? It's a very easy determination to make, and it saves us a lot of cycles. So it's going to look something like this. This is slightly deceiving animation because in actuality, it's not going to stop at the match there. It's actually going to go through, scan through the entire image, and then go back at the data it's collected, see where the highest correlation value is, and then say, hey, if that meets the threshold for this template, I'm going to say that's a match. So that's how we're doing the matching for the different logos. Right here we have the definition or the criteria for the canny edging algorithm. That's just the particular algorithm we're using to extract these edges. Very reliable algorithm and very efficient. That's why we made that design decision, in case you were wondering. So to cap this all off, this is the short version of the scale invariant template matching algorithm we're using. We're going to load in the input image. That's going to be the URL screenshot that we took. We're going to grayscale that. We're going to take the edges of that. And then with our template library, which we'll have to build up with all these different logos and services, we're going to loop through all those templates, check the whitelist. If the site's whitelisted, if we're looking at Microsoft.com or Gmail.com, we're obviously not going to want to continue classification. So we'll stop classification there and just output to the analyst that this site is whitelisted, this is probably legit. On the other hand, if there's no whitelist found, we're going to grayscale the template, take that edges as well, and then perform the template matching, capturing the highest correlation coefficient. And if that value meets our template's threshold for a true positive, we're going to mark that as true positive. We're going to check that, and then we're going to send that back to the analyst and let them know, hey, I found this logo, but it doesn't make sense that this logo is on this page. So you may want to look a little closer at this alert because it's probably malicious. And like I said, for the scale invariant piece, we're going to repeat this process over regular interval scale. So you could take 20 scale starting at 200% of the input image all the way down to 10% just to make sure we're covered in case they modified the size of the logo. And then we're going to build those results and write them to our cache result directory. It's pretty simple. All right, enough talk about the theory. We're going to try for a demo. We've seen how that's gone today, so hopefully it'll go well here. So I want to give a shout out to Michael Choate. He's here. I won't point him out, but he's here. He's the one who designed the lovely proof of concept you're seeing now. So let's just try google.com. All right, so this came up as a legitimate site, obviously because it's Google, it's whitelisted. But you can see over here, we're actually still getting feedback from those template images. And that's why it's important to set your thresholds at that certain level, because again, that Gmail logo, it can look like a lot of things. It can look like, any kind of M that's on this page, it might match up to that logo. So we have to set a higher threshold for that. We could do it for the BSides site. All right, legitimate site, because it didn't find any logos. Also, I'll say you have to be careful because these logos alone can be tricky. There's a lot of websites that aren't Facebook or Twitter that will have those logos in there because people like to show off their social media. Now let's try an actual creds harvester. I have a few samples loaded on here that we can try it out on. This first one's going to be an Adobe login page. Now we see the bread and butter of Phishualize here. So we have pretty positive matching up in the 90s and 80s for these logos. We have the Gmail logo, the Outlook logo, the Yahoo logo, the Adobe logo. It doesn't make much sense that all of those show up on the same login page, even though there's definitely users who would still fall for this one. So we're going to classify that as a potentially malicious site or malicious site. We can do it again for, let's say, Office 365. Oops. Or Dropbox. Same thing. If we're going through, Dropbox isn't going to ask you for all of your email credentials. It's going to ask you, a simple login screen for your email address and whatever password you have. So it doesn't make sense that we're seeing all these different services represented on this page. And then one more for O365. There you go. Once again, Microsoft Office 365 logo, but the site itself, the URL, is not a legitimate Microsoft site, so we're going to classify that as malicious. So again, nothing, super amazing about it. As long as you have the algorithms at hand, the template matching algorithms, you can implement this pretty easily in your own environment. And you take a tool like Phishualize, you can plug it right into your existing pipelines. There's a couple startups that are like just getting started doing this kind of thing as a service. But I would say if you have the development strength to develop this yourself, you should definitely go after it. Now, looking forward, again, this is a very young project, and obviously we need to scale it quite a bit if we're going to keep up with the amount of email that's coming in. So we're trying to explore different ways we can speed this up even more than the adjustments we've already made. One of those ways is exploring key point matching. Now, for those who are not familiar with key point matching, just a separate method for matching rather than template matching, we can do key point matching. Instead of having a whole template to match against, you can select these interesting areas called key points. What makes them interesting? Well, to a machine, what makes a key point interesting is the fact that it can be detected whether we rotate this image or scale this image or turn it black and white or decrease the brightness or increase the brightness. So what's nice about key point matching versus template matching is if an attacker were to catch on to how we're detecting their credential harvesters, all they would really need to do to defeat this Phishualize module is rotate their logo just a little bit, enough to throw off our template matching algorithm. Now, it's unlikely that they would do this, in a large degree, because if they rotate anything, any kind of logo on that page, it's going to tip off the human user who's looking at that page that something's weird. Why would they, rotate their logo all of a sudden? But if they did it, just enough, just a couple pixels, just enough to throw the algorithm off, it's a potentially defeating move that they're making. So we wanted to be prepared for that. So we've been exploring key point matching. The problem we run into is that to do pretty good key point matching, you need very good descriptors. And those are the things that describe all these little points, the scale, the orientation of that point, the intensity, the things that remain consistent no matter how you blow up this image or rotate the logo, whatever. And when you're working with all these tiny logos, it's really hard to get a good, robust set of key points and descriptors. And so doing some initial tests, we're using the BRISC algorithm. If you're familiar with like SIFT or SURF, those are actually patented algorithms, and BRISC is an unpatented version of SIFT, I believe. So we tried using BRISC, and what we found is that, yes, it's a lot more, it's a lot faster to use key point matching, but you sacrifice the fidelity of your detection there, because with these small logos, having maybe one or two key points that stand out in like the Gmail logo, you're not going to get the same results you would with template matching. So for now, we're sticking with the good old-fashioned template matching method, but we have introduced multi-threading, which has sped us up quite a bit. We basically spin up another thread for each template, and that sped it up so that we can scale it at least a little bit. And again, the end goal is that we can take this tool, we can plug it into our pipeline, and we'll see where it goes. And that's really it. I'd like to give a special shout out to Michael Choate. He put so much work into this project. Like, I just approached him like at the beginning of this year and said, hey man, I need help with this thing. Like, I have this idea, and we went with it. We just rolled with it, saw where it went. Also want to thank Adrian Rosebrock again. He provided, not only did he write 2 excellent books, which I dug into and kind of got an idea of where I wanted to go with this project, but I actually emailed him and we talked back and forth, and he provided a lot of code and advice on how to make this thing faster. So yeah, pretty short talk, but if you want to stay tuned for the status on open sourcing this thing, if you have any questions for me afterwards, feel free to come up or send me a message on Twitter or to my email account. And yeah, thank you guys for attending, and thank you for listening.